Welcome, everybody. As always, if you'd like to ask a question or similar during the stream, please do so, and we'll try to pick out some good ones and put them to the guest. If you think you might like to come on the show yourself, then please do get in contact. My details are in the channel's About page. Next week, we'll be talking with Greg Davil, but this week, it's Chris Fourie. Hello, Chris. Thank you for joining us.
Nice to see you again. Thanks. Wonderful to be here.
Would you like to just introduce yourself quickly?
Yes.
Say hi.
So, Chris Fourie, based in South Africa. I've been messing with electronics basically the past 10 years, building things, building biomedical devices, interactive electronics, and recently, about 2.5 years ago, I started working with Particle as a TSC first, and now a technical account manager. And I just love building things. So yeah, that's me.
Fantastic. And as I always like to start with sort of the where we came from side of things. You willing to talk a bit about school and how you got into the electronics?
Yeah, sure. I didn't have a clue what I was going to do with my life at school. I couldn't figure it out. Didn't do well, and then eventually landed on mechatronic engineering, which I applied to a program after a gap year, where I worked for a professor at local university my dad was also teaching at, and did a bunch of things. First job was cleaning an office.
Very good.
And then I went to the mechatronics program, which after about couple of months, I realized the end result would be a factory technician, which wonderful job, but not for me. I sort of fell out of love with the course. One of my final projects though was a PIC programming course where I had to control a stepper motor, which I found really fascinating, and I really enjoyed the programming aspect of it and building the electronics, figuring out how to drive a stepper motor with transistors, which was horrible and it was just shaky and didn't really work, but I enjoyed the process. So afterwards, I had a choice: do I buy a PIC or do I buy an Arduino? Which at that stage, this is 2012, Arduino was just becoming popular in South Africa, and you could buy one easily. It was still very expensive, like $40 in today's money.
Sure. Does that persist throughout electronics as well? You know that it's generally pretty expensive, PCBs and components and things.
It's really cheap actually. You can get stuff really cheaply these days. But at that stage, it was you imported everything yourself, or you bought it from a couple. This was an official distributor, and they had a huge markup on it, but it's almost double. So it wasn't fun. A lot of money in that sense. I blew up a was a Pro Micro, Arduino Nano, and that hurt. It wasn't like today where you could just buy one for $2, very easily. So had this Arduino, didn't know much, played around with a little bit, and then there was a project at the university that a student never completed. It was a M student mechatronics project, airflow sensor, and I was really fascinated by it. And overconfidently, I promised the professor, "I can fix this."
Let me add it. Yeah.
That was the beginning of the end, and I started digging in, spending late nights programming, figuring out how to use graphics libraries, bugging folks on the forum, the Arduino forums and the Adafruit forums. I was very active on at that stage. Amazing community. That's one of the things I've always I've always been really grateful for, the maker community, 3D printing community. It's amazing. It's open, and if you ask questions, people help you.
Want to share their knowledge. Yeah, it's fantastic.
Definitely. It's silly contrast, but my wife recently got a Cricut Maker, and that community, not good.
Oh, interesting. Okay.
They do not want to share. They do not. The local community, at least, it's everybody's like, you can't do this idea. I had this idea first. That's not my experience in the electronics community, especially on Twitter. I've really enjoyed everybody sharing their ideas and what they're working on, and that's been an inspiration. So yeah, I got started on this project, and that bit, and I found Adafruit because I want to charge a lithium-ion battery on a 555 LED dimmer
Mhm.
project I was working on. And I'm very lucky that I could work for my dad for quite a while, building biomedical device prototypes. So anything ranging from I've gone way past the education now.
That's okay. Take
Yeah,
it as it comes. Yeah.
yeah, it's all proof of concept designs. The idea of the company was basically to build these proof of concepts coming out of student ideas, and then present them to investors and get funding and move the
Okay.
projects along faster than they could have done in the academic environment.
Right. And
It
is
was
that
a
how you got
partnership
introduced to
program.
the university and access to that project which you helped with
Yes,
via your dad's
yes.
company?
So
Yeah.
yeah, I worked with a lot of. He's still a professor at the not that university. He's got 2 degrees.
Okay.
He's a doctor and an engineer. So
Right.
this was at the engineering part. So yes, that was my introduction. Worked with a bunch of engineers, and there was this challenge that the professor working on with the scanner had out, and he basically invited me to come take a look.
Nice.
Which I went, and I took along this little thing.
Okay.
The
Hang on a second. Let's make you
that's
big. There you go.
that's the bit on the CT scan.
Nice.
It's tiny. It is a Max. Which one is this? I've worked with too many of these. 86 160. It's an awesome little chip. It does pulse oximetry, and I believe this one does ECG as well. I can't
Okay.
remember which part number, but it's really
So,
nice. The sorry.
I was just going to say, for anyone curious who hasn't seen the CT scan, I've got that to share. And so
Yes.
that looks something like this. I'll just press play on that, and this is the cross section of that little tiny thing you held up in front of your finger. And this is fantastic. You can see the bond wires, and everything is just so clear. It's amazing.
And cost-wise, this was $100 to have this done, and I mean, it's a bunch of money, but compared to a PCB I made in 2012, which was also $100 for a single 10 by 10 PCB, I think this is really good value. And destroying this, which is a lot of time and money to figure out what the wiring is, which was the end goal. This saved so much time and got the project moving. Didn't go
Amazing.
anywhere eventually, but at
Never
that
mind.
point, it was a good investment of
Yeah.
money versus time, and it was really fascinating. I really enjoyed.
That's amazing. I've got the other one
process.
from the parallel view as well, which I'll just play out while we're talking. There you go. So this is now looking edge on to the PCB. So this was you were lucky enough to have access to the university first of all, and then someone at the university was willing to put your stuff in their CT scanner. Is this stuff that they did already, or is this sort of verging on new territory for them?
No. This is a project they've been working on for a while, but they do it as a commercial side project as well.
Okay.
Anybody can, in theory, go and scan.
Scan their
but I
electronics.
wasn't aware of this until I can't remember. I think my sister sent me the challenge. Somehow it ended up on Facebook.
Okay.
Yeah, but it's a really fascinating piece of equipment, and yeah, it's amazing. You can see the 4 layers of the PCB there.
Yeah, and the wires as well. If you scroll back, you can see there you got a
yeah, that's a blind wire.
That's exactly blind wire. It's amazing. Look at that.
Yeah, the solder and the voids in the solder. It's really fascinating.
Anyway, enough looking at. There you go. There's a full through via. Fantastic. Yes. So thank you for sharing that with everyone. That was out on Twitter a few years ago. I think you shared that originally, and I saw that and I was like, wow. You talk about X-rays and things, and it's very sort of subjective. You have to figure out what you're looking at, and you have to be really careful you don't make assumptions. But with CT scan, it's fantastic, isn't it?
That's the one benefit of the CT scan. And I believe I didn't have access to the full software, but you could. They can see which bits are which material, so you can highlight that in the full application as well, and do proper analysis and really dig into why something failed. And in this case, it was a bit of reverse engineering. But if you really want to dig into a piece of material that failed or cable that these really high quality cables. You can really see there's a void somewhere or whatever,
Yeah.
and then you can see the interactions, how well things welded together, for example. So it's quite fascinating.
Yeah, fantastic. There was another project you worked on at the biomedical sort of stage of your life,
Yes,
which was the needle sensor, I'm going to call it, which
yes,
sounded fantastic. Can you just sort of outline that for us as well?
yes, yes. I don't have an example, unfortunately, it's backed away. But there's a problem where if somebody's dehydrated, it's quite difficult to find their veins to inject or to draw blood. And there's a very complicated, very expensive device that you hold up here. It's got a thermal camera or infrared camera and a tiny little pico projector basically, and it projects an image on your arm, and you can see the veins. And you can sort of, they've got wonderful demos. You can hold, you can sort of stop the blood flow, and you can see where the valves are and everything. It's fascinating.
Is that sort
Really
of an
expensive.
augmented reality type piece of kit?
It
As in,
is. It
it's
is
visible
basically.
light that they project on the arm, and you can sort of highlight.
Yes,
Yeah,
it is. Yeah, it's a fascinating product,
yeah.
but it's expensive. It's something like $4,000
Okay.
each, and this lives in an emergency ward, and you can just imagine how easily those things can get damaged or bumped, or and it's expensive. And the way, so it's not practical. It's not practical to have anywhere in Africa, for example. The local environment just doesn't support having that type of equipment. So the goal was to create a in the needle tool that nurses in the field can use and easily find a vein when they need to. So the concept was to take a needle and put in fiber optics, and then you have LEDs at the back, sort of like a pulse oximeter. So you've got an LED and you pick up where the vein is, and you can actually directionally find the vein. So if you're pointing at a vein, you'll see a different response than pointing at muscle, for example. And then to augment this, there's a impedance component. So there's a thin little wire down the inside next to the fiber optics, and the needle itself is also one of the electrodes. And then you can pick up if you're in the muscle, in the blood, or if you're in fat, for example. So you're in the vein.
Can I just clarify? You've got my arm, for example, and you've got your needle.
Yes.
With the fiber optics, you're looking at the arm from far away, and you can see sort of through the skin, or
generally you know where you are.
Okay.
You've got a rough idea of where the vein is supposed to be, but if somebody is dehydrated, it's really difficult to accurately find that vein. So you'll insert the needle, and then you can sort of move it around and know you're pointing at a vein, and then you push it in. And you can also get confirmation, because my arm, it's easy to find. Like, I've got these big veins, you can see them easy enough. But if your arm is a bit thicker, or you're dehydrated, or your skin color is much darker, it's difficult to find that vein. And that's where it helps. But the impedance bit is really nice, and I tested it on a bunch of bacon.
Of course, yeah.
Worked surprisingly well.
Okay.
Yeah, that was it was a fun project, and that's actually gone to the not pre-production stage right now, but a company took the idea and they ran with it. So I think they're working on how to commercialize it.
Nice.
Funding is always a challenge.
Yeah, very cool. Yeah. So that presumably is, in terms of needles, they are, I think they're probably seen as consumables. They are one-time use, obviously, and that kind of thing. So that means that now you've got actually this quite high-tech needle. Is there much that goes into reducing cost and whatever else? Obviously, if you've got fiber and electrodes and everything involved in this, maybe there's some calibration.
Yeah, the needle itself, the aim is to make that as cheap as possible. So plastic fibers, and it's one electrode down the middle, and the needle itself, it uses the standard Lure lock, and that clips into what's basically the smart's little unit that you lock it in, and that's where the expense is. So that's a multi-use device, and then the needles are disposable. I think the cost of a needle was projected to be about double to 4 times a normal needle. So it's a little bit more expensive, but there are ways to bring down the cost. But yeah, it's not something you'd use on every single case, but if you need it,
it's a special case. Yeah, exactly.
Yeah.
Okay, that's fantastic.
It'll make its way into the market. I poor wife was at hospital one evening and they stuck her 12 times to find a baby.
Ouch. Yeah. Okay.
So yeah,
No, that sounds.
it'll save a lot of frustration, especially patients that have cancer treatments. It's really difficult to find veins.
Okay. Is that just a sort of an artifact of the treatments?
Of the treatment, the chemotherapy
Yeah.
is just
Okay.
not a
Interesting.
pleasant experience.
No. Very good. So that's yeah, very interesting project. Love to see it come to fruition someday. I'm sure you'll share it and point at it and go, you started with that, if it does.
Yeah.
Some of the other projects you did then in the biomedical field, I think you mentioned a baby monitor. You willing to talk a bit about that? Yeah.
Yes, I can show. This was the original. This is based off a really quick design based off a Adafruit Circuit Express. I think that's the name. They've got various Express units. So this actually clips onto Express, and then you've got Bluetooth. Because at that stage they didn't have either stock or use of the Bluetooth. This never worked. which is a recurring theme when it comes to prototyping. That is one experience that I.
Is this a project that didn't work and you understand and know why, or is it sort of one of those elusive ones that didn't work and then the funding ran out and whatever else, it sort of ground to a halt?
It was a combination of funding running out and we didn't have the software experience. The team didn't have the software experience, so we eventually did get somebody with the experience, and at that stage the money was gone for the project, so it's stuck on a shelf. Unfortunately, this was I think the second iteration. So this runs on an NRF 52840, and this was the final version. So it's a tiny little 0.6 mil PCB, which is, I mean, if you compare the two. Tiny. So this fits into a little thing. It's got a pulse oximeter on the one side, and we never got to that, but the final version would have ECG as well. So you could measure heart rate, and you could interpolate breathing from that as well. So this would get. The idea behind this is to, instead of one of those little pad baby monitors, which my kids used, and it's horrible. It wakes you up in the middle of the night for nothing.
So this is for at-home use, is that right?
Yes, the idea is at-home use. So you'd strap this onto your baby and basically know when, not necessarily something goes wrong, but you could track the average and see when an infection is headed your way. If you track temperature daily and heart rate, you'll start seeing differentiations from the norm or your baby's baseline, and that could indicate an infection up to 2 days in advance. So you can start treatment much earlier and bring the symptoms down, because that's one of the worst things. Your baby gets sick and you don't realize it. In the middle of the night, you wake up and you've got a temperature of 40 degrees Celsius, and it's not fun. So with this, in theory, tracking the baseline, you could prevent that.
So this is more of a sort of a long-term day-by-day monitoring rather than I know there are a lot of products out there for monitoring through the night. You know, if the baby stops breathing, if it rolls onto its front, that kind of thing. It's much more of the former.
Those, most of them they explicitly say they are not meant for SIDS monitoring, which is sudden infant death syndrome.
Sorry.
So they explicitly state they don't do that, but they do say we can help you detect it, in essence.
Not laughing at SIDS, but laughing at the escape.
The escape. No, it's a horrible thing. I've got 2 kids. That was one of our worst fears at the beginning. It's horrible thought, but there are these projects, and one was actually pulled by the FDA in the US for a while because they claimed it could detect SIDS, and the FDA said no, you can't do that. So that's also a tricky thing about the biomedical field is you need to be really, really careful about what you claim you can do, because it is horrendous, the regulations and everything else. That's one part I did not enjoy, is all the documentation.
Were you involved with that even at the prototyping stage? You were involved with, I from what I'm aware of, little as it may be, medical and automotive and various other things, you need to design the product from the beginning and document it all the way through.
if you choose this sensor, you need to say why you chose it.
Yeah.
What was the rationale behind this specific sensor instead of 5 other sensors? And it is painful, but fortunately, mostly prototyping work, so it wasn't that stringent. But there was a person on the team whose job this was, and I do not envy them.
No,
It was not pleasant.
I'm sure someone will enjoy it.
Yeah.
But
There are folks who enjoy it, and I have
yeah.
a lot of respect for them, but I do not want to be them.
That's absolutely fine. We each have our roles, don't we?
Definitely. Yeah. I enjoy breaking things and building things, but not documenting things.
So in terms of the justification for using a sensor, were you involved in that? Did you have to go out and test a handful of sensors and sort of give the data as to why you'd pick this particular one? Or was that something that someone else took care of? Or how did that happen?
No, this was, I was the electronics person on the team, and it was mostly up to me to decide which sensors we'll be using. But at the stage we were with the project was mostly exploration, proof of concept, just proving that the hypothesis was correct. So accelerated academic research in essence, but not research. It's just, we've got this idea. It's gone through a master's thesis, for example. They proved some of the bits. Now we need to see, is it viable? Is it possible to produce this at scale? And is there any commercial interest? Which, I'm based in South Africa, and to be honest, the funding this side of the world is non-existent.
Right.
Not for this type of venture, at least. That's one of the hard lessons we learned in the process.
Frustrating, yeah.
Yes.
So in terms of the approvals and things, again, sorry to keep digging on this one, but am I right in thinking there's sort of a differentiation between equipment which is used to monitor a patient and give you sort of advice versus equipment which is actually for diagnosis and hard numbers coming out of it, that kind of thing?
If this monitor was very much in the camp of, here's information, do with it what you will, and that's where the trend line is nice. You can alert like this is diverging from baseline. That is fine. You can do that, but you cannot say your kid has this disease or this condition. That is a diagnosis, and to do that, I was adjacent to a project where that was happening. That's a regulatory approval process with the FDA that is horrendously expensive and so much documentation, and you need an entire team doing all of that. And you need the justification, you need the research, you need the numbers. There's no shortcuts where if you're just gathering data, you can get away with a lot of things. And
interesting.
I mean, get away in a bad sense, but you just present data. That's what the baby monitor we used. It was basically just saying there's no movement. Here's an alert, but nothing else. And that's how they get. That's like they wake you up at 2 a.m. when nothing is wrong. But
fair enough.
It's there's definitely two camps. It's been a couple of years, but that's my experience.
Sure. Is there anything else you'd like to talk about in the biomedical field, or?
Not at the moment. There's another interesting project I can maybe just mention. When you intubate a patient.
So can you just clarify intubation for those that might not know?
Yes. You basically put an air pipe down somebody's throat if their throat's constricted for whatever reason. But the tube you put down, you shouldn't put into their stomach. You should put it into their lungs. And that's a tricky process if somebody has a constricted throat and you need to get that thing down there, and it's whatever situation you're in medically. You can be by the side of the road or anywhere. So it's always difficult to know how far in are you, and are you actually going into the esophagus or are you going to the lungs? So this is a project that it's a partnership between the KAUST University in Saudi Arabia and Stellenbosch here in Cape Town, and they developed a device that uses a Hall effect sensor and a very specialized intubation tube that has a magnetic tip. They use some sort of coating they put on it, and so they can actually use this sensor to see where this probe is and how deep down thing is. And you can see if it goes into the esophagus. So I was involved with that, and they actually did it on a cadaver, which is obviously not very pleasant, but they did x-rays, the really nice fancy medical x-rays where they go around the patient, and you could see where the catheter sits and versus where the magnetic sensor thinks it sits, and that's quite fascinating.
Yeah, that sounds awesome.
The biomedical field is very broad. There's a lot of applications. There's discs they insert into your back, and then there's it's sort of a stepper motor that you put into your back. So if you've got a compressed spine, and then you just click it once every now and again, if the got the doctor's name, but anyway, bone doctor decides it needs to extend a little bit, they just click it up. But the tricky part now comes in: how do you determine if that's enough, and how do you stop the device from just clicking all the way, doing more damage than good? So that kind of thing. So it's a risky field, but it's a really fascinating field at the same time.
Amazing. Pacemakers and things as well. They, as far as I'm concerned, they're terrifying devices. But
absolutely. Sorry.
No problem. Yeah. So you've moved on from biomedical a bit, and I think from there you went on to some interactive exhibits. Is that right? It's VR, Shockhead,
interactive,
and things like that. Do you want to talk about that?
Yes, a local interactive design company. That my first job with them was wiring a bunch of cables. It's horrible. I got paid nothing, but I persisted, and then they asked me to work on a virtual reality shark head. So it's this big, I don't know if there's photos on my Twitter of this, but it's this big shark head with at that stage we used the Oculus Rift.
Okay.
You sort of swim around as a shark, and then you experience all the senses. So there's sight, obviously, there's smell, there's a little fan in your face, there's vibration, and then there's audio. But on the outside, there's LEDs showing onlookers the progress within the game. Sounds really silly, but try and design that in a way you can make many of, and it will last for 5-6 years. In an environment where time is money. So that's always been fun, like just identifying the right connectors. So if a technician at the museum tries to plug something in, he doesn't plug it into the wrong port, for example, and blow something up. So that's been a lot of my. We've actually made the 4th version by now. They mostly in the US. There's an appetite for virtual shark games there for some reason.
I think I might have found some imagery of that. I'll just pull that up now. There you go. Is that right?
Yes, that's the most recent one, I think.
So that is looking towards the person, so the person will be standing at the other end of the table. Is that correct?
Yeah, that's the front of a shark head, so you'll be on the other side. I think there's a photo of that somewhere. Yes,
looking in. Yeah.
Yes, that's where you look in.
Amazing.
And yeah, so the current version uses a PC and there's serial communication, which isn't all that exciting. But the new version we're working on is all network based. So instead of using a PC, this was sort of in the Rift. The game works basically treats I forgot the name of the new Oculus.
Oculus Touch, I think, is what you said on that post.
No, that's the Quest 2. Yes, it's the Quest 2. So you can either run it independently or with a PC. So this one was running with the PC and serial comms, but the new one will run as an APK, so you can deploy it. And then there's network communication. So that's the new version we're thinking about. What was fun about that project is you need to enter the right menu, and for that you need to use the Oculus remote, but we've covered up all the cameras, so it can't see the remote, so the remote's nowhere. We initially tried to use a virtualized keyboard and mouse to press the right buttons on all the screens, but there's a slight drift in the Quest, so it works 5 or 6 times and then it just stops working. So the eventual solution was to just use the touch controller. But to get it to a point where the Oculus thinks it's in the right place, you need to remove and enable power. So this was my solution. This is there's a lot of space in there. So this is a AA battery replacement using a very expensive. This is about $10 for this reed switch, and this is a changeover version, so it's got both normally open and normally closed. And if you bring a magnet close to the remote, it pulls power and then it re-enables power, and the controller syncs. So
interesting.
Very silly little application, but this is where 3D printing really shined, because this is, I think it was about 5 or 6 iterations of just trying different sizes and shapes, and it needs to fit in. And I really enjoyed that process of just, I mean, it's a switch, but it took me 2 days to find the perfect one. And 3D printing is the only reason it exists. So
that's fantastic.
That's the fun part of the interactive electronics. I've built network connected, very LED diamonds that you use an RFID tag. You tag into the game, and then you start a game, and that was really fascinating. But the how do you fit this with its power supply and everything else in a small little space, and it needs to have everything needs to work, and the problem solving aspect of all of this has always been the biggest draw, and that's why I've enjoyed the interactive stuff, at least. There's always a fun we need to do this, can you
make it happen,
fix it? Make it happen.
Yeah. Is there any other interactive sort of exhibits and things that you're willing to talk about?
Yeah, I'm just trying to think of any more exhibits. Yeah, the other ones, it's been iterations of that, and a bunch of just power controllers and turning LCDs on and off. And it sounds simple, but you design one controller that uses infrared, works on 90% of the screens, and then somebody comes along and they build these professional grade screens. They buy the panels from LG and Samsung, but they implement their own controller, and that picks up the infrared, but somewhere between the picking it up and passing it along to the display, it doesn't work. So they're just getting serial comms working and everything else. So that's always been every single time is different. This is a fun little project.
Oh yeah,
this is not a exhibit. I've mentioned this before the call. It's one of those Hub 75, very bog standard. Everybody and their dog has built a project on these, and they do the little flips and stuff. This is a contact from Interactive Design. They put me in touch with this company, or folks who want to build this. So using ESP32, this is the Room version, this is the Room, Rover. More pins, but it's built in SPI Flash as well. So really nice, except you lose a bunch of functionality. The bottom pins are basically useless, so it looks like it's got a lot more functionality. But this was built in last year, or the design was done last year, and that has been...
Can you just give us an overview of what this is?
Sorry. Yes, this is a interactive kids game. So this is one of the bits, and then you put it in and you sort of tilt it, and a bunch of things happen. I'm not involved with any of the software. I'm just building the hardware. So, but it's got a couple of hall sensors. It's got an IMU. It's a 5-volt boost circuit. Try and find one that is affordable and works really well at 3 amps.
That's quite a bit.
That was a challenge.
So what battery or power source are you using for this?
Just the standard lithium-ion 2000 milliamp hour battery, which is pretty beefy. This is a SD card, basically. So it's one of those XT SDs. I think Greg DeVore was the first one to find it. And then Adafruit put it on a breakout board, and this is the 1 gig version.
Nice.
Or 512. Works really well, works really nice. I'm quite impressed by it. Had a lot of fun. This is a 4-layer board because the original was 2 layers, and try getting audio to work without buzzing if you've got a 5-volt boost on the board. That was unpleasant.
Audio is one of those things, isn't it, where you can very easily accidentally make a problem incredibly obvious. And buzzing, for example, is not a good place to be.
No, the original board somewhere, I didn't think about it at the time, and this is an analog amplifier, so it's not digital.
Hmm.
And the traces went all the way down, 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 all the way over there, but it crosses absolutely everything, and
Hmm.
it's just a mess. So you turn the amp on, it's just zzz. So not fun. It's got an MPU 6050 on, which is ancient and expensive right now,
Hmm.
but that is the only IMU I could find in quantity.
Okay, so
The
that's just
five
the
volt
pain of the chip shortage we're dealing with still, isn't it? And
pain of the chip shortage. This 5 volt boost, you can't buy it. So I have, I think, one left, and that's it. So
oh no,
the
yeah.
the unfortunate reality of this entire project is this is a proof of concept, just getting the software working, and then it needs a redesign, and that is the reality of 2022.
Mhm.
And I'm so tired of it.
So you had some frustration with that IMU, I think recently. I saw some things on Twitter.
Yeah.
Do you want to
The
expand
best
on
way,
that one slightly?
the best way to clean a PCB, hands down, is an ultrasonic bath. Except if you've got any MEMS components. I found that out the hard way, and by some miracle, I did not clean the original board. I hand soldered, and this was the most frustrating thing because I was running these boards through all the tests, and for some reason the IMUs just reported zeros, and the values wouldn't change. And on the z-axis, it was slightly off. It never showed -9, so gravity
Yeah.
basically, and it's just the weirdest behavior. And every single board differed, and I would replace a component, and then it would work. What's going on? And
And by replace the component, you're talking about the IMU specifically. So you had a few extra,
IMU
did you?
specifically.
Yeah.
Yeah,
Okay.
I fortunately had one or two extras, but again, it's unobtainium right now, so
Yeah. Yeah.
couldn't do much. But I suspected the library, I suspected my wiring, I suspected everything. And then I realized, but the first board I have works. I tested this before I soldered all the rest. I had them soldered. And I was racking my brain, and then I realized the only difference between board number 1 and the other 14 is I never cleaned board number 1 in the ultrasonic bath. And it was about 11 p.m. at night, and I was Googling the data sheet, and I searched for ultrasonic, and up comes a nice little warning from never clean MEMS devices in an ultrasonic bath.
Oh no.
So that was a bad moment, and you can see this board is populated.
Yeah.
So now you need to desolder that component right in the middle. Fortunately, these headers weren't there, but I can't find it right now. I've got this PTC 200 watt AC, which is very dodgy. Heater, little aluminium extrusion heater. It works excellently. It was $14 or something. It works really well. You just turn it on and heats up. Pulled the parts off. Pulled them off a breakout board I bought for way too much. It was about $60 to replace all of these, and way too much time.
Yeah.
But now they're working, and I will never make that mistake again.
Very good. Mental note made. So one of those mistakes, as you say, you make it once and then you learn from it in the painful way. So
I think,
these carry on.
Sorry. No, Jimmy DiResta from YouTube, he's got a maker channel. He builds everything. He has a statement. He always says, "You go to school on the first one,"
Yeah.
and that's exactly what I did.
Yeah. So the MEMS devices that you've pulled off, I presume that I've not looked into this at all, but I presume the ultrasonics actually physically damage the structures of the MEMS device. I'd love to see one of them through a CT scanner, just to see, sort of lying off to one side or whatever it is inside.
I've been tempted to. I still have them somewhere. I've got them in a little thing. I've been thinking about it, but still, it's $100 to scan. So not right now. But I would like to get them scanned because yes, the MEMS, it's capacitive sensors, so it's little fins. I'm not sure about what the MP6050 looks like, but it's a structure that sits like this, and then it vibrates. So that whole thing is probably just skewed to one side, which is why they never changed. And only in the Z direction did you the Z direction was completely frozen. So from all that shaking up and down, it probably just got stuck and wedged in on the side.
Yeah. Okay.
Yes, it would be fascinating to see that amount of damage, because they're completely destroyed. No, it was a unpleasant surprise.
Yeah. Fair enough. So your job today, you are tech support at Particle, is that right?
Yes. Funnily enough, thanks to Twitter, I was made aware of a opening at Particle as a developer support engineer in 2019, which I then applied for. The Iden Argon, Particle Argon, that's a Wi-Fi feather form factor device, and it couldn't claim it to my account. So I wrote in, and the support engineer saw my email address, and he Googled my URL, and he found my Twitter profile. So I was looking for work. And
oh no!
A couple of weeks down the line, we're opening up a position. So why don't you apply? Which I did.
Amazing.
And then, I was fortunate enough to get the position. Met the team when I was at SuperCon, the last in-person one, which is a shame. It was really good. Met the team there, started working as a developer support engineer, technical support engineer, now technical account manager. So yes, support basically, and that's a fun job. Helping customers figure out what's going on, why their devices are not functioning as expected. A lot of the issues are connectivity related, but it's also a really fun job. So I get to work on all the new stuff. So this is the new P2 Wi-Fi development kit that was recently launched. So this is really fun, helping customers get this. Let me show this briefly, but this is a cool little SKU from a customer, and this is another one. No names. So helping them get that figured out, production lines, how to flash devices in production. It's a ever-changing role, ever-changing new challenges every week. So it's really fun.
So from the Particle point of view, they produce modules which people put into their IoT devices, is that right? And your role really is to support them in getting them up and running, getting them on the platform, make sure that their product works, and as you mentioned just now, flashing in production, that kind of stuff. Yeah.
The overall team is technical success. So yes, getting customers up and running and make them stop bothering us is sort of the goal of the team. If they don't bother us anymore, we've been successful at what we do. But yes, that's the goal.
How do you defend your time, I suppose? If you have a customer who comes to you with initial connectivity problems, for example, and then you help them resolve that, do they then often come back with unrelated problems that actually it's not your job to resolve? And how do you deal with that?
We've got a pretty strict support policy in terms of what is covered and what's not. We don't do firmware development, for example. I can't. And that's also for legal reasons. If we tell somebody, yes, this will work, and it doesn't work, then we're in trouble. The US is quite litigious, unfortunately. So no firmware development. It's platform or device issues. There's also obviously it's enterprise support mostly. If you're not paying for support, you get less attention. That's otherwise it's impossible to run a business. It's pretty much like any support team. So there's limits, and then we just gently let customers down, which is a skill I've learned in the last 2.5 years. That's certainly been an interesting aspect of the job is customer interaction, which I'll be honest, I never thought I'd enjoy being a support engineer, but it's really and now the technical account management stuff is really fun working with customers.
Fantastic. And so I presume that part of your role as well is a lot of training on your own platforms. I think people call it dog fooding, that kind of thing. Really understanding what you guys have to offer.
That's why I've got this, and that's why I'm bugging engineering every week, asking them to explain why this isn't working, or why is this working, and how is this working, and what should I be doing? And can we get this resources for customer, etc. That's also an interesting skill set, and not annoying the engineers.
So I think Particle's a US company, and you're obviously South
Yes.
Africa. So how does that work for you? The
Yes.
time zone, is that something that you consciously picked? Is that something that they're flexible with? I presume they're not asking you to be in the office sort of once a week, for example, that kind of thing.
No, no, no. There's no office close by. The US Particle's about, I believe, 55% remote,
Okay.
and they've always been remote, happy with remote folks. And when COVID hit, everybody was remote for the majority of the time. Sales is mostly they still need to meet customers, etc. So
Hmm.
that's a time proven process. Um, but yeah, it's difficult in the sense that if I want to speak to an engineer, I need to be up late at night. But if I can start late, and yeah, there's a lot of flexibility. So
Okay,
been
that's really
that's
nice
been
to
great.
hear. I know that some
Yeah.
people, myself included, actually sort of enjoy the late night working. So I was wondering
But
if
yeah,
maybe that was part of what you're into as well.
I I'm a complete night owl. It is
Yeah.
12:15, and I'm not close to tired. Quarter to 12.
Very good.
Yeah.
Great. Very nice. So we mentioned 3D printing earlier, and I can see a whole stack of filaments, I think, behind you. Um,
Yes, that's my experimental batch.
very good. What's your favorite thing that you've made? Can you just describe some of the
Ooh.
problems you've approached, that
Um,
kind of thing?
this is one of the most fun to figure out. It's so
Okay.
silly and pointless, but it works so well, and
So
it's only possible.
I was just going to say, could you give us more insight into that? It is literally just a battery with a reed switch, or is there actually any
It is
sort of...
it is literally a battery with a reed switch. So it
Okay,
replaces a double A with a triple A, and
right.
there's a reed switch in line. There's two. I think that you can sort of see it in there, but that's it's a copper clad, so
Hmm.
dual layer copper clad, two wires soldered onto that. It is so simple, it is silly. But you can't do this without 3D printing. There's no
Yeah.
way to produce this, and especially in a week's time, you need to figure out this problem. You can. I printed 5 or 6 versions, and the final one was resin printed, and it works. And
Yeah.
you can refine it. Like the angle's not right, so just increase the angle a little bit and print it
Yeah.
again. And a
Yeah.
couple of hours later, you've got a part. I'm trying to think of my favorite thing I've 3D printed. I'm not sure. I don't print that often as I should. I've got a love-hate relationship with resin printing. It
Okay.
is
You have a resin
absolutely
printer as well, do you?
amazing. Yes.
Yeah.
I got a really good deal, like $300 for a Creality LDR dash double 02R. I don't know how they figure out this naming schemes, but anyway,
Okay.
so it's a tiny little resin printer.
Hmm.
Best upgrade ever is the magnetic build plates, which you just
Okay.
peel the part off. Otherwise,
Yeah.
it's a mess. But it's the quality is staggering. The amount of detail you can get out of a part is just amazing. And it takes a couple of hours. You've got this batch of parts. You can use them in anything. You can prototype with them. We've mounted vibration motors on parts printed on this printer, and they're shaking away inside handlebars for the shark head, and they work. And that was also a case of the design was sent away to a company to do this, and they came back and it never fit. And we did 5 iterations and it finally fit right. And
Hmm.
it's 3D printed, and that's just, I find it fascinating. And something that it was available a couple of years ago, but you paid 100 grand for a machine, and it's just
Yeah.
unaffordable to most people. And it's just but yes, resin printing is a mess. It is it is a complete mess. It stinks. It is when I made the mistake one time of not wearing a mask, and I had the worst headache of my life.
Oh no.
It is not good. So
So
yeah,
do you leave
it
the
is
room,
one of
or
my.
do you have sort of
I
ventilation
actually
for the
had it in
printer
the.
itself? Or
I actually kept it in the garage because it
okay.
was just too bad.
Yeah.
It's not good. But yeah, good ventilation is important. The Prusa Mark 3S Plus is the best 3D printer I've used. A filament printer, you press play and it prints, and
Hmm.
you walk away, and you come back a couple hours later. There's your part. So
Yep.
that's a wonderful workhorse, especially with the magnetic build plates. And then my other favorite tool is a laser cutter, which also very specific use case, but if you need it, you need it, and it works really well. You can produce parts really quickly, really accurately. Silly little box, but I mean, you can't. 3D printing this takes a couple of hours. Laser printing this takes. Laser cutting this takes 20 seconds. So it's a also a really neat tool to have. And I went for the BMO beam box. It's the smallest of the units, but it's got the camera. It's got enough power for most materials, and it is just amazing. And you can use it day in and day out. Really nice. The K40s are great if you want them, but the camera makes all the difference because you can really reuse materials quite a lot, and you can.
So what's the camera for? What does that do?
Basically gives you a view of the cutting area, so you can position your files where you need them instead of guessing.
Oh, I see.
It sounds silly, but it makes the world of difference when you position material.
Yeah, okay. So I've seen CNC machines where they will sort of draw a perimeter around your target, and you have to make sure that it doesn't cross some void or whatever. And that sounds actually really good. Yeah, nice.
Yeah, there's a bit of parallax error, and I think the other big one that does it is Glowforge, but you can't buy them in South Africa. Their parallax compensation is a little bit better, but in general, I mean, if you've got this much material left and you need to cut something that big, there's no chance for mistakes. So the camera helps a lot with that. There's a marking material I found you can print on PCB stencils. It works really nice. Marks really nice. Does really nice black marks on it. So there's a lot of applications where you just can't get away with, or it's just impractical to do with another tool.
No, very nice. So you got a couple of 3D printers, resin and filament. You got a laser cutter. You mentioned your wife's got a Cricut.
Yes.
Have you used that yourself, or is that kind of her toy?
Yes, I've played with that. That is it's a really horrible tool, and it's a really good tool
okay.
at the same time. It's horrible in I'm coming from the open source movement where if I want to redesign the Prusa, I can. Like all the files are available. I can do what I like. I can 3D print something and it fits. On the Cricut, you need to buy their very expensive cutters. You need to buy their very expensive. You don't need the materials, but it works better with their stuff. Same as the Prusa Mint, which is fascinating, amazing. But you can't. They've got a knife blade, but they've obviously realized, and it uses a knife blade as X-Acto knife, basically. But they've obviously realized if they open up the material, if you can create any type of material, you can use this knife blade for almost anything, and you never need to buy their very expensive tiny little knife blades, which are like 3 times the price and doesn't last so long. So they've locked you into only certain materials with knife blade, and you can only do these with the deep blade, and you can only do these with fine blade. So there's no option to customize. You've got like medium, hard, and soft pressure. That's it. Right. So in that aspect, I do not like it, but it does a really good job. You get printable vinyl, and I've made a little sticker shard and made these stickers for SD cards. You can print out that little sticker, and it's wonderful. It just works. The vinyl. The vinyls look great. My wife made a bunch of T-shirts for the kids. Every time we've got an event or she does horse riding, so every time there's a show, she'll print a bunch of shirts just for the fun of it, and it looks great. So yeah, it's a wonderful tool, but I keep on asking myself why there's no open source vinyl cutter, because besides the creative stuff, there's so much with masking and stencils, and again, it's one of those tools where if you need it for specific things, it really helps having that tool. It's impractical to do anything else. It's a pen plotter. You can do these amazing little drawings with it, and it looks really great, because there's something it just looks so nice to have something drawn by a pen versus something printed. It's
Absolutely.
silly,
I
but it does look
completely
really
agree.
good.
Yeah.
Yeah.
Amazing.
And you do get these plotter machines for a couple $100, but it's not. Yeah, I want to open source Final Cut one
There
day.
you go. Fair enough. Yeah. Have you got any other exciting tools that you might talk about? You mentioned your hot plate.
This is. Yeah, I can't show you the hot plate because I don't know where it is right now. But this is one of my favorite little tools. It's expensive, but if you work in IoT, this is something everybody should have. And I just disconnected it. It's the OT Arc. It is intended for IoT stuff. It's a battery simulator in essence, but it's got not the most accurate, but it's got really good accuracy in terms of power measurement, and because it integrates serial, this is a particle device, so you can watch the modem power up, and you can see the logs. Modem's doing this, the modem's doing that, and you can see the current traces exactly as it happens, and you can see if it goes to sleep. It's actually going to the sleep levels it should be going. So that's a really useful little tool that I quite like quite a lot.
Yeah. Does that? So you said it's a battery simulator. Does it operate as a power supply, and it just pretends to be a battery in terms of discharge curves and internal resistance, that kind of stuff?
Yes.
Amazing.
Yes. Yeah. The battery bit is, you need an extra yearly license, which I don't like, but as a power supply at the voltage levels you specify, it works really well, and obviously it does the measurements. You can give it an external load resistor, so you're not limited to just its accuracy, for example. But the integration, it's mostly down to the software. I mean, a power supply and measuring with a scope or a very good multimeter, you can measure current draw really well, but the integration of the software with the application is sort of where it shines. And that's, I think, where Prusa Slicer, for example, makes the Prusa printers very usable. Obviously, they've open sourced it to other printers as well, but that's where it shines, the integration.
Yeah, fantastic. Yeah. Very good.
Silly, but this is
carry on.
One of my other favorite tools. Stick vise. This is one of the best things. Like, anybody doing electronics should buy one of these. It's just it's a stick, clamps and stuff.
It does so well, doesn't it? Yeah, I've actually got two over there. That's so good. Yeah. Great. So I think we're coming up on time. Is there anything else you'd like to mention or talk about or shout about quickly before we wrap up?
No, I think that's everything. I'm just very grateful for all the folks on Twitter, especially in the electronic space. I know Greg's following me up, so that's hard to beat before. His work is fascinating, but the openness of the community and the amount of sharing and the knowledge sharing is why I'm here today. Everything I know is, if I run into a wall, I can ask somebody, and there's an answer. There's not, and that's where I contrast the cricket community to the open source community. And it's not cricket necessarily, but there's a closed source. It's a different mindset. I was so startled when I saw people didn't want to share ideas. If you copy their ideas or did something similar, they would be sort of feisty about it, and that's not the experience I've had with electronics, and just sharing ideas, people contributing to KiCad, which I still should learn. There's so much openness and so much sharing, and that's just amazing, and I'm so grateful for that. And that's why I share the random CD scans on my Twitter, because I find it fascinating, and I hope other people would find that either inspiring or fun. I don't know.
Yeah. I certainly appreciate it, and I completely get what you mean about the open source community. It's incredibly welcoming, so thank you, everybody. Yeah. Very good. Well, thank you very much for coming on this week. It's been really good to talk.
Thank you for having me.
Done some fascinating projects. Just before we close, we'll be talking to Greg Davil. I've messed up at the beginning as well, I think. So it's Greg Davil next week. Looking forward to that. And aside from that, goodbye from us.
Bye, everyone.